Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of laws of exponents. This is standard A.11B in the great state of Texas, and we are using item number 13 of the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find an equivalent expression to this whole mess right here. And the values are going to be defined for m, p, or v. That means we're not going to have any zeros. Because if any of them ended up being a 0, we divided by 0 as a denominator, then it's going to mess it up, be undefined. So let's split this up into like terms. This is what I'm saying. When I see this, and they've even lined them up for us, I see 45 over 15. I'm just going to use the distributive property to kind of break this up. M to the negative 6 over m to the negative 2. P to the 2 over p to the 8. And then v to the 12 over v to the negative 4. Okay, so if we split it up like that, we can deal with like terms in the similar basis, right? So 45 over 15, that's pretty simple, right? We've got our 3. So automatically, I'm not liking C, I'm not liking D. Assuming it is going to be a full fraction, it looks like it's going to be in the numerator, right? I've already eliminated 2 answers because I'm just looking at coefficients here. The rest need to be the same bases. The bases are these big numbers, or these big variables, the m, the p, and the v. So you can deal with each of those separately. All right, so we need to think of our laws of exponents. So first thing we need to keep in mind is negative exponents. So I'm seeing that over here for m to the negative 6 and m to the negative 2. What that tells us, if you have a to the negative n power, we see this in our mathematics chart or reference materials, it's 1 over a to the n. You just flip it to the other side of the fraction. You take the reciprocal. So this ends up being 1 over m to the 6th over 1 over m to the 2nd. Having both of those in fractions makes it look kind of weird. It ends up meaning you end up taking that m to the 6th down here, but then you take your m to the 2nd up here. They just flip spots. The 2nd and the 6th stay there. So now we just have to think of the quotient of powers. Okay, so what happens when we divide 2? Well, we have a to the m over a to the n. You end up keeping the base and subtracting both exponents. Okay, so that's going to end up being m to the 2 minus 6, right? So that's going to end up being m to the negative 4, which means it's just going to go down below. Okay, so I'm going to end up making a fraction down here. So m to the negative 4 ends up being 1 over m to the 4, right? So I'm just going to put m to the 4 down there, right? So now I'm looking at b. Okay, let's see. I've got my p to the 2 over p to the 8. So once again, we're going to end up subtracting, right? So p to the 2 minus 8 equals p to the negative 6, which equals 1 over p to the 6. So it looks like my p to the 6 is going down there. Let's just check my v. Okay, so my v is going to be, and I can still subtract, even though it's a negative down there, right? I can go ahead and subtract. I can say v to the 12 minus negative 4. Well, 12 minus negative 4 is going to end up being the same as v to the 12 plus 4, which is v to the 16. Now, it's not a minus, it's a positive, so we're going to put it up here at the top. Okay. Another thing we could have done is we could have just taken that v to the 12 and then brought that v to the 4 up, since it was going to be the reciprocal. And if you ever get two that are multiplying, you end up adding the 2. It would be v to the 12 plus 4, which is what we just did over here. That's the multiplication of powers. But either way, our answer here is going to be B.